Our next question is point A, B, C are the midpoints of sides of triangle PQR respectively. So first of all, let's draw triangle PQR and plot the midpoints at their respective places. So here we have triangle PQR with their midpoints A, B and C. Now we have to find the slope of line containing each side. That means we have to find the slope of PQ, QR and PR respectively, or we can say RP. Okay. Now here, using the properties, or we can say geometry of the triangle, we will come to know that PQ is parallel to CB line. Similarly, QR is parallel to AC and PR is parallel to AB line, right? So we can say their respective slopes will be equal, right? So using this property, let's try to find out slope of PQ, which is equal to slope of BC, right? Before we find the slope of BC, let's collect the coordinates of B and C. Coordinate of B will be 3, -1 and the coordinate of C will be -3, 4, right? So we are ready to find the slope of BC using the definition of slope. M is equal to y2 minus y1 upon x2 minus x1. We simply have to take a difference of y coordinates as well as x coordinates. So let's take the difference of 4 minus -1, or we can say 4 plus 1 upon -3 minus 3. So -3 minus 3. So here we will get 5 upon -6, or we can say -5/6, right? Similarly, let's find out slope of the second edge, which is QR, which is equal to slope of AC, right? Now let's collect the coordinates of A and C, which are -2 -1 and -3, 4. Okay, now let's find out the slope of AC using taking the difference of y coordinates 4 minus -1 upon -3 minus 2. So it will be 5 upon -5, or we can say -1. Now the last edge, which is PR, slope of PR, which is equal to slope of AB. The coordinates are 2, -1 and 3, -1. Now let's take the difference of y coordinates -1 minus -1, or we can say +1 upon 3 minus 2, but we will get 0, right? So we get our final answer. Slope of PQ is -5/6, slope of QR is -1, and slope of PR will be 0. Slope of PR equal to 0 suggests that our PR line is horizontal line, right? Here we have our next question, in which we have 4 different points: A, K3, B, 2 -1, C, 0, 5, and D, 6, 7. We have to find the value of K for 2 different cases. First one, AB line is perpendicular to CD line. And second case, AB line is parallel to CD line. Now, we all know that if lines are parallel to each other, then their slopes are equal. And if they are perpendicular to each other, then the product of their slopes will be -1. So to use this property, first of all, we have to find the slope of AB as well as CD. So let's begin our sum. First of all, let's find slope of line AB, and as we know, for that we have to collect the coordinates of A and B, which are K3 and 2 minus 1, right? So we are going to use the second formula of the slope, in which we have to take difference of y upon difference of x. So let's take difference of y, 3 minus minus 1, or we can say 3 plus 1, upon difference of x, k minus 2. So here we will get k minus 2, or we can say slope of AB will be 4 upon k minus 2. It will be slope M1. Similarly, let's find out slope of CD line. Here we have the coordinates 0, 5, 6, 7. Okay. Now let's take difference of y, 5 minus 7 upon 0 minus 6. So we are going to get minus 2 upon minus 6, or we can say 1 by 3 as our M2, right? So here we get the slopes. Now let's use the conditions which are given in. The first condition is AB is perpendicular to CD. That means the product of slopes will be minus 1. So we can say M1 into M2 will be minus 1. Let's place their values. M1 is 4 upon k minus 2, and M2 is 1 by 3 is equal to minus 1. If we simplify the terms, we will get 4 is equal to minus 3k plus 6, or we can say k is equal to 2 by 3. Tada! We will get our solution of first case. Now we should go for second phase, in which AB is parallel to CD. That means M1 is equal to M2. So let's place their values. 4 upon k minus 2 is equal to 1 by 3, or we can say 12 is equal to k minus 2. So we will get k is equal to 14. Tada! We get the answers. Our k in first case is 2 by 3, and in second case our k will be 14. Okay. We have 4 different points: P minus 1 2, Q 7 6, R minus 1 5, S 0 3, and we have to prove that PQ line is perpendicular to RS line. For proving this thing, we will use the slope of the lines, and we know that if lines are perpendicular, then their products will be product of slopes will be minus 1. Okay, so first of all, let's find out slope of PQ line, and for that we are going to need coordinates of PQ minus 1 2 and 7 6, and we are going to use the second formula of the slope, difference of y upon difference of x. So let's do difference of y, 6 minus 2 upon difference of x, 7 minus minus 2, or we can say 7 plus 1. So here we are going to get 4 upon 8, or we can say 1 by 2. Similarly, let's try to find out slope of another line, RS, and their coordinates are minus 1 5 and 0 3. for finding slope, let's take the difference of y, 5 minus 3 upon difference of x, minus 1 minus 0. So here we will get minus 2. Okay, so let's call first slope as a m1 and second one as m2. And as we can see, m1 into m2, which is basically 1 by 2 into minus 2 is minus 1, right? So if product of slope is minus 1, that means PQ line is perpendicular to RS line. Hence proved. Ta-da! This question, we have to prove that point A minus 1 4, point B 2 3 and point C 8 1 are collinear using this slope, right? Okay, now let me show you graphically that if this is our line and if A, B and C are on the same line, then we should consider that the slope of AB, or we can say slope of BC, must be equal, right? So let's try to find the slope of AB and BC. First of all, let's try to find slope of AB, and their coordinates are minus 1 4 2 3, right? Okay, now we have 2 points, so we will use m is equal to difference of y upon difference of x. So let's take difference of y, or we can say 4 minus 3 upon difference of x, minus 1 minus 2. So here we will get 1 upon minus 3, or we can say minus 1 by 3 as our first slope m1. Now similarly, let's try to find slope of BC line, and their coordinates are 2 3 and 8 1. Okay, now let's take difference of y, 3 minus 1 upon difference of x, 2 minus 8, or we can say 2 by minus 6, or minus 1 by 3, which is our second slope. Now here we can see that m1 is equal to m2 is equal to minus 1 by 3, and AB line and BC line have common point B, right? So we can say AB line and BC line are the same line, or we can say A, B, C are collinear. Ta-da! Hence proved. This question, we have to find the slope of perpendicular bisector of AB section, where A is 2 6 and B is 0 minus 1. First of all, let me remind you what is perpendicular bisector. Perpendicular bisector is a line which is perpendicular to line AB and passing from the midpoint. So using this property, we can say the product of their slopes will be minus 1, and it is passing from x1 plus y1 by 2 and x2 plus y2 by 2 point, right? But the first property is useful for our example, right? Okay, so let's visualize this question. If this is our line A, B, then our perpendicular bisector must be perpendicular to this line and passing from its origin. So let's assume the line is L and its slope is M2 and the slope of AB is M1, right? So here we should find out slope of AB for getting the slope of L, right? So let's find slope of AB line, and we know that to get this we are going to need the coordinates of AB, and here we have 2 6 0 comma minus 1. Now to get the slope we are going to use difference of y upon difference of x. So let's take difference of y, 6 minus minus 1, or we can say 6 plus 1, upon difference of x will be 2 minus 0, and it will give us 7 by 2, right? And as we decided earlier, let's call it slope m1. Now slope of line L, which is perpendicular bisector, is m2, right? And we know that AB is perpendicular to L, so we can say m1 into m2 must be minus 1, right? So 7 by 2 into m2 must be minus 1, or we can say m2 must be minus 2 by 7. Ta-da! This is the required slope of perpendicular bisector. In this question, we have to find the slope of line which is passing through origin as well as midpoint of the AB. First of all, let's visualize this question. Suppose this is your origin, point A and point B, and our line which is passing from origin and midpoint, this will be L, right? So L is first passing from origin and second point which is midpoint of AB. So first of all we have to find this midpoint to get the slope using difference of y upon difference of x, right? So M is the midpoint of A and B, and the coordinates of M must be 3 plus 1 by 2 and 1 plus 5 by 2, right? Or we can say M must be 2 comma 3, right? Okay, now we just have to find the slope of OM, and for that we have to mention their coordinates, and here we have, now we just have to take the difference of y upon difference of x. So tada, we have the slope of OM is equal to 3 by 2, which is your required answer. Now here we have one interesting question. We have to prove using slope that if we connect the midpoints of any quadrilateral, then it will form a parallelogram, right? So first of all, let's draw an quadrilateral. Here we have a quadrilateral ABCD with their coordinates x1 y1, x2 y2, x3 y3 and x4 y4 respectively. Now according to our question, let's get the midpoint of the sides. The midpoint of the AB, let's assume as a P, Q R and S. Okay, so the coordinate of P must be x1 plus x2 by 2 and y1 plus y2 by 2, right? Similarly, we can find the coordinates of Q, R and S, right? Now we have to connect these midpoints PQ, PS, PQ and QR and finally SR. The question is, we have to prove that PQRS is nothing but parallelogram, right? Now you understand the question. Okay, after understanding the question, answer will be simple. To proving the parallelogram, we have to prove that the opposite edges must be parallel to each other, or we can say their slopes must be equal to each other. So indirectly we have to find the slope of PQ, QR and RS and PS respectively, right? So let's begin with this PQ edge. To get the slope, we have to take the difference of y or upon difference of x, right? Here, as you can see, by 2 will be cancelled out, and y2 and x2 will be cancelled out, and finally we will get y3 minus y1 upon x3 minus x1, which is the slope of PQ. It's just a beginning. We have to find the slope of QR also. તો જરા ટેન્શન વગર આપણે હિંમતથી slope of QR find કરવાનો try કરીએ. And let me get the coordinates of Q and R. And here we have, okay, now we just have to take the difference of y coordinate, or we can say y3 plus y4 by 2 minus y2 plus y3 by 2 upon difference of x coordinate, which is x3 plus x4 by 2 minus x2 plus x3 by 2. Okay, now by 2 will cancel out, and y3 and x3 will cancel out. So finally we will get y4 minus y2 upon x4 minus x2, right? 2 edges down, 2 to go. Now let's go for third edge, slope of QS, and let me get the coordinates of Q and S for you. Sorry, RS. Then we just have to take the difference of y upon difference of x over here. In this case, by 2 will cut, y4 and x4 will cut, right? So we will get y1 minus y3 upon x1 minus x3, or we can say y3 minus y1 upon x3 minus x1, which is exactly equal as PQ, right? So here we prove that PQ is parallel to RS. Now we just have to find the slope of remaining edge, which is SP, right? Let's get the coordinates of S and P. Here they are. Now just take the difference of y coordinate upon difference of x coordinate. Then by 2 by 2 and y1 and x1 will cancel out, and we will get y2 minus y4, which is exactly equal, or we can say we can make them equal, right? So ultimately we get slope of PQ equal to slope of RS, and slope of QR is equal to slope of PS, right? So we can say PQ is parallel to RS and QR is parallel to PS. So finally, proudly we can say PQRS is a parallelogram, right? Ta-da!